So, so today we are going to discuss paper number 10. I hope all of you have written paper well. चलो start करते हैं. What we are able to see here, a conducting wire has length L1 and diameter D1. After stretching the same wire, the length it becomes L2 and D2. Okay, sir. So we are having a wire, and this wire is having length L1, and this diameter is D1. There is a length L2, correct, and this diameter is going to decrease little bit, and I don't go on my diagram, has been decreased. So we are able to see, sir, volume whatever is there, it is same, है ना, because area multiplied by length is going to be our volume. I can see that all the answers is in diameter, so I'll write R equals to rho L by A. Now can I write this as, can I divide, can I multiply and divide by area? So what do I get? Rho into area multiplied by length, it is volume, and area multiplied by area, it is A square. So I can see that rho is not changing, volume is also not changing, and resistance is only directly proportional, only inversely proportional to area square. Can I write it as R1 by R2 equals to A2 by A1? Yes or no, bacho? Sir, what is A2? But say area in the terms of diameter is pi d square by 4, correct? Area of a cross section of the this part wire, correct? So pi r square, and instead of writing in radius, we are writing in diameter, so it is pi d square by 4. So here we are getting pi d2 square by 4 divided by pi d1 square by 4. Sir, this we are, and also there is a square on the top of it also, correct? So basically we are going to get here d2 to the power 4 divided by d1 to the power 4. All right, sir, this is, so I'm able to get option A. I hope you read it correct in the exam. All right, question number 2, what we are able to see, sir, a point charge is surrounded by 8 identical charges at a distance r as shown in figure. Okay, sir. And how much work is done by the force of electrostatic repulsion when the point charge at the center is removed to infinity? Acha, sir. So we are able to see that what is the work done by electrostatic force. Sir, I know something, sir. Negative of the work done, potential energy is basically negative of the work done by conservative field force. Yes or no, bache? So can I say work done is going to become U, it used to be U final minus U initial, so it is going to become U initial minus U final. Acha, sir. So basically you are asking me to calculate initial potential energy and final potential energy. Okay, what is the initial potential energy of this system of the charges when Q is in it? We are able to see this is going to become, for one charge it is going to become K Q1 Q2 by, acha, formula what is for potential energy? It is K Q1 Q2 by R with sign, correct? When two charges are kept at a distance r. So right now we are able to see that potential energy for one charge is going to become, it would be k q square by r. But what is the total potential energy due to all charges? It is going to become all potential energy of, it is going to become 8 q square by r. All right, sir. Sir, so basically this is my initial potential energy. When this charge is going to go to final potential energy, है ना, what would be the final it is, they are taking it to infinity, so basically final potential energy is going to be 0 because of this charge, correct? It is not going, it is basically going to be out of the system. So what is my work done? My work done is going to become initial, which is 8kq square by r, minus final, which is 0. So I can write it as 8q square by 4 pi epsilon naught r, and this is my work done. Now 8q square by 4 pi epsilon naught 8q, so this is my option B is correct. Okay. Now one might think, sir, what about the other charges? They must also be having some potential energy among them. हाँ बच्चे, they must also be having some potential energy among them, but even when the charge at the center is gone, they still exist. So whatever the initial energy of the system was there, the change will happen only because of the removing of the center charge. So we need not to worry about that. Correct? All right. Solve the next question. Sir, electric field is expressed as E equals to 2I cap plus 3J cap. All right, sir. Potential difference between A and B, between 2 points whose position vectors RA is given I cap plus 2J cap, and RB is 2I cap plus J cap plus 3K cap. All right, sir. Sir, I know a relation. It is E equals to minus dV over dr. हाँ बच्चे, करेक्ट रिलेशन है. dV equals to, we can write it as minus E dr. All right, sir. Sir, I want to calculate potential difference between A to B. So if I'm going from, let's say if I'm going from A to B, and I'll need to put RA to RB here. Correct? A to B, basically position vector I need to write. So here I am going to write what is the integration of this dv. It is going to become vv minus va. I am having here minus, and this is my e integration. E कितना है बच्चे यहाँ पे? It is 2i cap plus 3j cap. It would be multiplied by dxi cap plus dyj cap. Correct? dr vector से multiply करेंगे. So we are going to get now what are the limits of, so when we are going to multiply 2i cap dxi cap, it would be basically 2dx. And when we minus is there बच्चों, है ना, minus is there. And then we are able to see here, when we are going to multiply this will be 3 dy. And what are the limits? Sir, I am going in I में I am going from 1 to 2, and I am in this I am going from 2 to 1. Okay, sir. All right. मुझे बताओ यहाँ पे what is VV minus VA for you? Sir, VV minus VA is going to become here 2, and it is going to become 2 minus 1, it would be 1, plus अच्छा minus again, it is outside, and this will be 3, and it is going to become 1 minus 2. Correct? So it is going to become minus, and this will be 2, and this is going to become minus 1, so it is going to become minus 3. We are able to see that this is minus 1, and this is minus 1 multiplied by minus 1, it is going to become plus 1. So VV minus VA is plus 1 volt. But sir, in the question they are asking VA minus VB. अच्छा बच्चे, so VA minus VB answer is going to become minus 1 volt. बच्चों ध्यान रखना है, whenever these kind of questions are going to come, they will always have something where they're going to have at least one negative answer of the similar sign. Yes or no? So make sure that you are doing it properly. Correct? So one thing is that this right now we are able to see that field is constant. You can basically directly also multiply the vector. Okay? So what do we have here now? We are having here next one, capacitor having capacity of 2 microfarad. Okay, sir. What is the capacity? It is 2 microfarad charged to 200 volt. Okay. Plates are connected to a resistance of the wire. The heat produced in joule will be. Okay. So we are able to see basically there is a resistor and there is a capacitor. And this capacitor is basically charged. So this capacitor is charged, and then it is connected to this resistor. So it is charged, so obviously it is going to have some energy. What is the energy? It is going to have half CV square. So half into, what is C here? 2 into 10 to the power minus 6. And what is the voltage by which it is charged? 200 square. So which is going to become basically, this is cancelled, 10 to the power minus 6. It becomes 4 into 10 to the power 4. So it's basically 4 into 10 to the power minus 2. Correct? So this is coming in joules now. Sir, the plates of the capacitor are connected to resistor wire. The heat produced in joule will be. Sir, all this capacitor is going to get basically discharged, and all this energy will be basically used in heating. Yes or no? Or basically wastage as heating. Clear? So can we say that basically it is the same amount of energy that is going to be wasted here? Yes, sir. So it is going to become 4 into 10 to the power minus 2 as my correct answer. ठीक है बच्चों? Now, what is the next question? So find the work done to take a particle of mass m from the surface of the earth to the height equal to 2r. Okay, sir. So we are able to see there is a particle here, है ना, earth पे. and right now it is going to have some potential energy. What is the potential energy it is having? It is having potential energy minus gmm by r. What is the final potential energy it is going to have when it is going to go to height 2r? It will be minus gmm by 3r. So what is the change in potential energy, sir? U final minus U initial. So it is going to become minus gmm by 3r, and it would be plus gmm by r. Correct? Where m is the mass of the earth and small m is the particle, and r is the radius of the earth. Correct? So what we are able to see here, it is going to become basically r. You can take common, it is going to become 1 minus, can we take common here, it is going to become g mm by r, and here we are having 1 minus 1 by 3. So this is going to become 3 minus 1, this is 2 by 3 gmm by r. Sir, gm by r I can write it as gr. Yes or no? Correct. So can I write it as 2 by 3, and this is going to become m. This is g equals to gm by r square relation. Correct, bacho? So it is going to become gm by r. It is going to become mgr. So this is my change in potential energy, and it is also my work done by the external force. So what is option is correct for me? It would be 2 by 3 mgr. Correct? D option will be correct. All right. Now what is the next question? Next question we are able to see here. Charges Q, 2Q and minus Q are given to the three concentric conducting shells. As shown in the figure, the ratio of charges on the inner and the outer surface of the shell C will be. So we are able to see that in this shell, conducting shells are there. So conducting shells are there, that means charges are going to appear. So if this is charge Q here, sorry, this is charge Q here, so how much charge is going to come here? It will be minus Q. Sir, what is the total charge on the shell number 2 is 2Q. Acha bache, so if it is minus Q, here it is going to become 3Q, so that the total charge is basically 2Q only. Bache, if this is 3Q, this is going to become minus 3Q. If this is minus 3Q, outside it has to be, the charge on the shell has to be minus Q. So outside it is going to become 2Q. Now what they are asking me, they are asking inner they are asking ratio of the charges on the inner and outer surface of the cell C is. अच्छा सर, तो C पे कितना आ जाएगा हमारे पास? अरे बच्चों करेक्ट ऑप्शन नहीं है. Basically it is going to become minus 3Q by 2Q. We are able to see that it would be minus 3 by 2 as the correct answer. Correct? Alright bachcho. Now what is the next thing? Sir, we are able to see a galvanometer of resistance 50 ohm. So what is the galvanometer resistance? Sir, Rg is 50 ohm converted into ammeter by connecting a low resistance of value 1 ohm. अच्छा सर, शंट रेसिस्टेंस वैल्यू कितना है सर? 1 ohm. पैरेलल टू द गैल्वेनोमीटर. फुल स्केल डिफ्लेक्शन, बेसिकली गैल्वेनोमीटर करंट कितना है हमारे पास? गैल्वेनोमीटर करंट है हमारे पास 10 मिली एम्पियर. करेक्ट? दिस इज द गैल्वेनोमीटर करंट. नाउ दे आर सेइंग व्हाट इज द मैक्सिमम करंट दैट कैन बी मेजर्ड. अच्छा, आपको पता है ना कि गैल्वेनोमीटर इज बेसिकली समथिंग दैट ओनली डिसाइड्स in which direction current is going. It does not measure, it is used for only detecting very small currents. So here we are able to see that we are adding a shunt resistor to a galvanometer. Now this galvanometer is there. Galvanometer says that please do not give me more current. Yes or no? So we are giving here I, some current Ig will go here and I minus Ig will go here. Now this is my shunt resistance, this is my resistance of the galvanometer. Now I know that Rs, I minus Ig must be equals to Ig Rg. Sir, I can write it as basically I minus Ig equals to Ig Rg by Rs. Yes or no? So here I could be written as Ig 1 plus it would go on this side, so it is going to become Rg by Rs. Sir, what is the galvanometer current? So galvanometer current is 10 into 10 to the power minus 3. 1 plus, what is Rg here bache? Rg we are able to see galvanometer resistance, which is 50, and then we are having shunt resistance, which is just 1. So it is going to become 10 into 10 to the power minus 3, and this is 51. So it is going to become 510, and into 10 to the power minus 3 I can write it as milliampere. So my answer is going to become 510 milliampere. All right, sir, very nice, sir. In the conductor, in the condenser shown in the circuit is charged to 5 volt and left in the circuit. In 12 seconds the charge on the condenser will become, acha sir, so basically they are charging it to 5 volt. What is the meaning of they are charging it to 5 volt? That means the total charge on this is going to become how much? Q equals to CV, and C is 2 and V is 5, so it is going to become 10 coulomb directly, है ना, because everything is given in farad and this. So it is 10 coulomb, sir. Very nice, sir. So now they are leaving it in the circuit. So basically what would happen over a certain period of time, the capacitor is going to discharge, and they are asking charge in the capacitor after some time is. Sir, we know that when the capacitor is going to discharge, it is going to discharge with a function Q equals to Q naught e to the power minus t by tau. Q is the left out charge, sir. Q naught is the charge in the beginning, and this is E minus t by tau. What is tau, sir? Tau is called which a time constant. It is CR. What is the value of C here? Sir, it is 2. And what is the resistance here? It is 6. So it is going to become 12. Now they are asking also mean 12 second. So t value is also given to me 12 second. So basically it is going to become Q equals to 10 to the power e to the power minus 1. 12 by 12. Yes or no? So that will be 10 by E. That should be the charge after 12 seconds. So 10 by E shall be my answer. Correct? What is the next one we are having? A uniformly charged ring of radius 3a. So we are able to see there is a ring and that is having radius 3a. And a total charge Q is placed in XY plane. And मैं ऐसे बना ले रहा हूँ, आई एम मेकिंग इट इन द एक्स जेड प्लेन बेसिकली, एंड वाई से चार्ज मूव करा देंगे, कोई टेंशन तो नहीं है आप लोग को. ऑल राइट सर, दिस डिस्टेंस इज बेसिकली 4a, and from here we are able to see a charge here, and what is the charge here? Q moving towards the ring, and this radius is 3a, and the charge on the ring is also Q. The minimum value of U such that it crosses the origin. All right, sir. Right now we are able to see this is basically a positively charged ring. Sir, if there is a charge Q and this is also positive charge, it must be given some velocity so that basically it can reach here. So basically the minimum amount of velocity, all these questions can be done by conserving the potential energy, conserving the energy, my bad. So now tell me, what is the potential energy in the beginning plus kinetic energy in the beginning, and what is the potential energy final plus kinetic energy final? So potential energy initially, there is basically this ring and this charge is there, correct? So potential energy, because of these two, it will be there, and kinetic energy will also be there, bache. What is the kinetic energy? Because we are giving it some velocity. Sir, what is the potential energy in the beginning? Sir, potential energy in the beginning, again it would be kq by r. So this is going to become kq, but q and q is going to become q square, but the distance is going to become this r, bachu. So this is 3a, this is 4a, this is going to become 5a. So this will be 5a plus, and we are going to give it some energy. Let's say, what is the energy here? Half mu square. We are going to give some velocity u. Now what is the final potential energy? Sir, it is going to reach to the center. When it is going to reach to the center, it would be kq square by the distance between this and this. So basically we are able to see what would be the potential energy here. It would be kq square by 3a. All right, sir. Acha, some of you might get a doubt, sir. Right now the charge is basically on the total charge on the ring is there. How do I know that? This formula is basically for point charge. So you know that potential at the center of ring can be calculated, and then you multiply it by the charge, and that is going to become basically the potential energy. Very nice, sir. So this is half mu square. This is going to become kq square by 3a minus it is kq square by 5a. Sir, we can take common kq square by a. It is going to become 1 by 3 minus 1 by 5. Sir, this is going to become 15a. This is 3 5s minus 5 3s. So this is going to become multiplied by kq square by, that's it, right? So we are able to see if m is going to, this will be 2 by m and this will be u square. Now basically can I say that u is going to become 2 by m multiplied by 2 by 15a multiplied by 4 pi epsilon naught and q square also. Yes. So let's see the values and check. So we are able to see here, this is root 2 by m. We can, everything is in root 2 by m, so we'll take root 2 by m out and again root. So we are having here, as a q square is also inside, so basically we are having 2 by 15 q square by 4 pi epsilon naught a. B option looks to me correct. Yes or no? Root 2 by m, 2 by 15 q square by 4 pi epsilon naught a to the power 1 by 2, which is basically same thing. All right, bacho. So next one, when the separation between two charges is increased, the electric potential energy of the charges increases, decreases, remains same. Sir, what is the potential energy of the charges? It is basically k q1 q2 by r with sign. Sir, if the positive charges are there and you're going to take them apart, correct? If you're going to take them apart, when they are closer, they are having more potential energy, but they are going to be far apart, it is going to be less. But same will not be, it would not be same for the negative charges. When negative are there, they are having negative potential energy together. Let's say one of them is positive, one of them is negative, the total potential energy is negative. But when you're going to pull them apart, the total potential energy is going to become zero basically. So we are able to see increases, decreases, remain same. It may increase or may decrease depending upon the sign of the charge. Correct? Now what is the next question we are having? So 4-point charges Q are placed on XY plane at this. Okay, sir. So we are able to see that there is some coordinate system, and here it is 0 comma 2, and here it is 0 comma minus 2, and here it is 4 comma 2, and here it is 4 comma minus 2. Very nice, sir. Now they are asking me the work required to put a fifth charge q at the origin of the coordinate system. So we need to put a, okay, there are already 4 charges are there, q q q q, and I want to put a fifth charge here. So the best way to do this is, sir, let's calculate the potential at this point so that we know what is the potential of the origin and what is the work done, basically potential at the origin multiplied by charge. So what is the potential here, sir? Potential is going to become potential due to the first, let's number them, 1 2 3 4, correct? So potential due to 1, how much it would be? kq by r. So what is the r here? It is going to become 2. Yes or no? And then what is v2? V2 is also going to become kq, but this is going to become this is 4 and this is 2, so it is going to become kq by root 20. What is the potential due to third one? Potential due to third one would be, sir, it would be kq by root 20 again, and this will be due to the fourth one. Fourth one, it is going to become kq by 2. So we are able to see that total potential is going to become here 2 kq by 2 plus 2 kq by root 20. All right, sir. So basically, what is my potential energy or work done? Work potential, change in potential energy. Initially, we could see that there was potential. Now, if we are going to multiply with charge, it is going to become potential energy. So can I just do, this is going to become root 20 could be written as 4 into 5, root of 4 into 5. So it would be 2 root 5. So now I can write it as kq 1 plus 1 by root 5. Now potential energy is going to become basically kq square 1 plus 1 by root 5. Yes or no? So, and this could be written as q square by 4 pi epsilon naught 1 plus 1 by root 5. Correct? So which option is correct? I think B looks the correct option. Yes or no? Yeah, B looks the correct option. Now, what is the next one we are having? Sir, battery of 3 volt is connected to a resistor dissipating 0.5 watt of power. So basically there is a battery and it is connected to a resistor, and this battery is of 3 volt and it is power of this resistor is 0.5 watt. All right, sir. Terminal voltage of uh, this battery is 2.5. What is the meaning of terminal voltage? Sir, what it is able to provide across its terminals. That means there is a voltage drop in the voltage drop in this is happening 0.5. Correct? And what is the terminal voltage? It is 2.5. Total is this. We know that, sir, V equals to IR and V equals to small voltage drop it I multiplied by R. And we divide these equations, sir, we are able to see this is 2.5 divided by 0.5, and this is same current, and this R is just one resistor, so it would be R by R, and R by R is going to become 5 for me. Okay, sir. Sir, why did we calculate this? What is the need for this? All right, they are asking is power dissipated within the internal resistance, where R is the internal resistance. Correct? Now, if R is the internal resistance, what would be the power formula? So power formula is I square R in the external resistance, and it would be I square R in the internal. So basically current is same. So power is going to become basically PR will be R by R. So R by R is 5. So it would be 5 divided by PR. So PR is going to become basically 0.5 divided by 5, which is basically 1 by 10, which is 0.1 watt. Correct? So 0.1 watt will be my correct answer. Now the next question we are able to see is there are certain physical quantities are given and matching we have to do. Okay, so drift velocity. So drift velocity formula I know it is E tau by m. Correct? So it is E tau by m. So A will be with R. A with R. Okay, all R. Then we are having electrical resistivity. Sir, electrical resistivity for sort of time, sir, I forgot, I don't know. Let's see current density. Sir, current density though I remember, sir, it is I by A. Bache, so what is I formula? It is NEAVD by A. So it is going to become NEVD. Okay, sir. So basically A is R and D is for sure Q. Is there anything? Acha, sir. So D is Q and A is R in this also. Now I need to know one more in order to figure out. Alright, bache. So what we are having? Something called relaxation period, tau, and electrical resistivity. Sir, electrical resistivity I know, sir. Basically it is electrical resistivity I know, sir. It is basically rho equals to R equals to rho L by A. Yes or no? So rho is basically RA by L. So this formula, I think this is having some hunch, sir. I'll solve it, sir. This is E divided by J. J is I by A, so it is going to become. And can I write E as V by L into A by I? So now tell me what is V by I? This is basically our R. So R A by L. Array, sir, this is to my resistivity only. Haan, bache. So we are able to see that B is going to become S. So A is R, B is S, and D is Q. So basically C is P. So this and this formula also you should remember, relaxation time period. Uh, Basically it is a row formula. So it is M by N square tau. So you just remember it from here. Always one question comes. I would request you to just Make sure that you know all these questions. All right. Now next one we are able to see, as shown in the figure, a point charge Q is placed at the center of the conducting spherical shell of inner radius A and outer radius B. The electrical field due to charge Q in three different regions is. Sir, when the charge is placed inside, sir, inside field will be there, sir. Yes, bache, field will be there. So who's saying field is not there? Field is not equals to 0. Haan, sir, field is not equals to 0. In the second region, this is conducting material. So if we are going to keep a charge in the cavity, the some electrons will be there. Basically, they are going to attach themselves. Basically, they are going to move in this side and they are going to make the field 0 here. So in the conducting material, field is always 0. Outside also we are going to have some field that will be there because whatever the charge we are going to keep inside the cavity, that will appear outside. Why it will appear outside, sir? Q you are keeping here, minus Q, it will come here. So basically there will be a left out positive charge Q on the outside of the surface. So basically field inside the cavity is not 0. In the cavity is in the conducting material it is 0, and outside it is not 0. So inside it is not 0, in the cavity it is not 0, in the conducting material it is 0, outside it is not 0. So basically our third one is correct answer, but sorry, my bad, our fourth one is the correct option. Yes or no? E1 is not 0, E2 is 0, and E3 is not 0. All right. Next one, a point charge of 10 microcoulomb is placed at the origin. At what location on the x-axis should a point charge of 40 microcoulomb be placed so that the net electric field is 0 at x equals to 2? So that the net electric field is 0 at x equals to 2. Okay. So 10 microcoulomb is placed at the origin. So this is our 10 microcoulomb. And there is another charge which is 40 microcoulomb here. And this is some point, let's say this is 2 centimeter and this is some r centimeter. We know that electric field is 0 here. Because of this it will be away from it, because of this it will be away from it. So it is going to become kq by r square equals to kq by r1 square equals to kq q1 q2, correct? So kk cancels, sir. Q1 is how much? 10 microcoulomb. R1 is 2 centimeter square, and it is going to become 40 microcoulomb divided by R2. So this is going to become 10 4s, and this is my 4, 1 by 4, and R2 square is going to become basically 16. So R2 is going to become 4. If R2 is 4, from here to here, from here to here, how much distance it is going to become? It would be 6. Now there are options. There could be, you might think, sir, why electric field might not be 0 here, but say this is positive charge, so away, because this is also positive charge, so away, it will not be 0 here, correct? Same can be said for the other side. Now what is the next question for us? Sir, for a uniformly charged thin spherical shell, the electric potential radially away from the center O of the shell can be graphically represented as. So we are able to see here potential, they are talking about shell. Sir, in the shell I know field is 0, sir, correct? Inside the shell, such charge always resides on the outside, the field is 0. And potential, I know that since field is 0, so potential will be constant. So I can see, sir, there is one graph that is having potential constant inside, and this is another graph. But sir, outside it does not vary linearly. I know it is kq by r, so it is going to vary with respect to 1 by r. So my D options has to be correct. Very, very popular graphs. You shall work on the other graphs also, which are having conducting, non-conducting, solid conducting. So now they are saying equivalent resistance between A and B. Equivalent resistance we have to figure out. Okay, sir, what we do is we add an imaginary battery. So if this is potential V battery, this is going to become 0, this is 0, so this is also 0. So this is V, so this is also V. So we are able to see that between V and 0, there is a 20 kilo ohm, correct? This is V, this is 0. Sir, another one is between 0 and V, this is also between 0 and V, this is also 20 kilo ohm. Sir, this is also between V and 0, this is also 10 kilo ohm, correct? Yes or no? So we are able to see, sir, these all are in parallel. If they are in parallel, what would be our R equivalent? 1 upon R equivalent, it would be 1 by 20 plus 1 by 20 plus 1 by 10. So we are able to see 21 plus 1 plus 2, which is going to become 4 by 20, which is going to become 1 by 5. So R equivalent is going to become 5, and this is basically 5 kilo ohm. So it is going to become in 5 kilo ohm. Correct? So A option will be correct. Now, a Wheatstone bridge principle is used to measure the specific resistance S1 of a given wire having length L, radius R. If X is the resistance of the wire, then a specific resistance S1 is X multiplied by pi R square by L. If the length of the wire gets doubled, then the value of the specific resistance is, okay, sir, they are saying, sir, basically specific resistance rho is RA by L in with all this language. Now they are saying rho, what would be the value of rho if the length of the wire gets doubled? So we can see that in the formula. But sir, resistivity is the property of the material, है ना? It does not depend upon the length. So basically, if it is S1 for a given wire, it would remain S1 for the same wire, no matter if you are changing the length or you are changing the area. Correct, Pacho? Now next one. So next question is, a parallel plate capacitor has plate area 40 centimeter square. The plate separation is 2 mm. Alright, sir, area is 40 centimeter square and D is basically 2 mm. Correct? And we are filling a dielectric of thickness 1 mm. T कितना है बच्चे? 1 mm. And K is also 5. The capacitance of the system is, basically, we know that when half is filled, half is unfilled, it is going to become basically looking like a parallel capacitor. But we also know that we have a direct formula for it also, right? It is epsilon naught A D minus plus T by K. If you are filling some part of it. So it would be epsilon naught into 40 into 10 to the power minus 4 divided by D is 2 mm minus 1 mm. It is 1 into 10 to the power minus 3 plus 1 into 10 to the power minus 3 divided by, it would be 5. So it is going to become 1 into 10 to the power minus 3 is common. So 1 into 10 to the power minus 3 is common. We are having basically here 5 plus 1, that is 6 by 5. So this is going to become 5. Now when it goes to the top, it is going to become 40 into 5 by 6 into 10 to the power minus 1. Correct? So which is basically 4 into 5. 4 into 5 is 20. 20 by 6, it is 10 by 3. But so there is epsilon naught as well. Correct? So basically this capacitance is going to become 10 by 3 epsilon naught farad. Correct? So that is our answer. What is the question number 20? Question number 20 says 3 charges 2q minus q and minus q are located at the vertices of an equilateral triangle. So let's say we are going to take an equilateral triangle and we are able to see that there is 2q and there is minus q and there is a minus q. Alright, sir. So we are able to see that at the center of the triangle, the field is 0, but potential is non-zero. Achha, potential is going to become 0 at the center. Easy as a kq by r, yes or no? And field, sir, field is a vector quantity. So it is going to be here, this is going to be here, this is going to be here. So basically there will be some net field. The field though cannot be 0, correct? So both field and potential are non-zero. No. The field is non-zero, but the potential is 0. B option has to be correct. What is the next question? A simple pendulum has time period t1 when on Earth's surface and t2 when taken to a height r above the surface of the Earth, where r is the radius of the Earth. The value of t2 by t1 is. Bache, so simple pendulum has, what is the time period of a simple pendulum, sir? T equals to 2 pi root L by g. So basically nothing is being changed, only thing is being changed is g. So I can say that it would be 1 by root g. Now when we are going to go to Earth height, some of r above, so this is going to become basically g value is going to become g dash. It would be gm r plus h whole square So this will be gm, this is r plus h, it would be 2r square, this will be 4r square. Now gm by r square is g, so basically it is going to become g dash will be g by 4. So can I say T1 by T2 equals to root G2 by G1? Yes or no? So T1 by T2 is basically root G2 is how much? G2 will be G by 4. So it will be G by 4. So it is going to become T1 by T2 would be 1 by 2. So T2 by T1 will be 2. Correct? T2 by T1 they are asking. So it will be 2. So time period will not have any unit, it's just 2. So what is the next question? 10 resistors, each of resistance 10 ohm. So what is the equivalent resistance of this? I can say that they are able to see maximum and minimum. But maximum ke liye we are going to have 10 resistors, each of 10 ohm are connected. So basically R1 plus R2 plus R3 in series. So when we are going to do it, 10 resistors are there, है ना, and they are each of 10 ohm. So basically this is going to become 100 ohm. And what would be R minimum? So R minimum, how much it is going to become? Uh, Basically one, if we are going to connect them in parallel, that would be basically 1 by 10 plus 1 by 10 plus 1 by 10 10 times. So that will be basically 10 by 10, that is going to become 1. So what would be the ratio we are going to have here? Ratio maximum to minimum equivalent would be 100 by 1. It is going to become 100 ohm. Correct? Now what is the next question we are having? In the given figure, the total charge stored in the combination is 100 microcoulomb. The value of x is, we can see that all of these are in parallel, bacho. If they are in parallel, what would be the combined capacitance? It would be 2 plus x plus 3, and if we multiply with the total potential, we are going to get the total charge in microcoulomb. So this is going to become 5 plus x into 10 equals to 100, right? So 5 plus x equals to 10, so x equals to 5. Now this value of x will be 5 microfarad, because this charge was in microcoulomb, so this will be in microfarad. So value of x has to be 5. So what is the next question we are able to see here? They are saying two identical charged spheres are suspended by strings of equal length. The strings make an angle theta with each other. When suspended in water, the angle remains same. If the density of the material of the sphere is 1.5 gram per centimeter cube, the electric constant of water will be. Acha sir. So we are able to see that basically they are equal length. So this is also L, this is also L, and they are having some angle with theta with each other. So I'm taking with vertical. So they are saying now for example, if they are having same material, this will also be having mg. So when they are going to be suspended, since they are repelling each other, same charge, this is going to become t cos theta. This will be their electric repulsion force, and this will be their t sine theta. Correct? So this is our theta. Can I write t cos theta equals to mg, and can I write t sine theta equals to f? Now this is equation number 1 and 2 when they are outside in air. When they are going to be put in dielectric, the equation is going to change, but the angle they are saying is not changing. In dielectric, angle is not changing. In dielectric, basically they are having some okay, so dielectric constant of water they are asking. Basically there will be some upthrust also, right? So if upthrust is going to be there, what would be t cos theta? It would be t cos theta plus upthrust, which is density of the liquid multiplied by volume submerged. It is v rho g, and here we are going to have mg. Here the force is also going to change because now it is in dielectric, so it will be F dash, which is going to be F by K. This tension will also change. It is T1 cos theta at this point. Correct? This is going to become T1 sin theta. Sir, can I write it as T1 cos theta equals to mg minus v rho g and T1 sin theta equals to f by k? हाँ बच्चे बिल्कुल लिख सकते हैं. Sir, from here I am able to see that tan theta from here is basically f by mg, and from here tan theta from here is f by k mg minus v rho g. Correct? How much? In both cases tan theta is same, so we can say that it is going to become f by mg equals to f by k mg minus v rho g, right? F cancel, so we are able to see that. Can we write this mg? Let's write mg is density equals to mass by volume. डेंसिटी इक्वल्स टू मास बाई वॉल्यूम. सो डेंसिटी को अपन लोग बच्चे सिग्मा मान लेते हैं. दिस इज आर सिग्मा, दैट इज अ मटीरियल डेंसिटी, राइट? सो मास इज गोइंग टू बिकम सिग्मा वी, mass is going to become sigma v, correct? So this is going to become sigma vg equals to k times sigma vg minus v rho g, correct? बच्चों vg will cancel, so we are having here sigma divided by sigma minus rho as k. Now what is k here? Dielectric constant for me. Now I want to calculate the value of k, right? So what would be the k value here? K value is going to become sigma, which is my material density 1.5, and this is 1.5 minus water density is 1. So it is going to become 1.5 divided by 0.5, which is 1 by 2. So it is going to become 3. So k value is going to become 3 for me, correct? The electric constant of water. Now we are having question number 25th. What is the question number 25th? So in the following circuit, the battery has an EMF 2 volt. All right, sir. And the internal resistance is 2 by 3. Okay, sir, we can see that. Power consumption. So power consumption, we know V. I need to just find R equivalent. So can we find R in the entire circuit, not in the outside, entire. So we need to calculate the entire ka R equivalent. What would be the R equivalent for this? So you can basically have we are able to see that we can have a folding symmetry here. So we are going to fold, it is going to become basically 2 ohm, 2 ohm, 2 ohm, and there will be 2 ohm here, and then you're going to have, because of these, you're going to have 1 ohm, and you're going to have 1 ohm here, right? Correct? So this is going to become now 1 ohm. My bad, I made a really bad diagram. So when you fold it, basically this point and this point will go, this point and this point will go, so you're going to have 2 ohm here, right? And this will be in parallel, so this is going to become 1 ohm, and this will be in parallel, so this will also be 1 ohm, correct? So this is going to become now 1 ohm, 2 ohm, and this is going to become now 2 ohm, 1 ohm, and this is now 1 ohm here, and here we have 1 ohm, and here we have 2 ohm. Yes or no? Correct. So here it is going to become 2 into 1 divided by 2 plus 1, which is our R equivalent. It would be 2 plus 1. It is going to become 2 by 3, correct? So R equivalent is coming 2 by 3. Now down also we are having 1. So total R equivalent is going to become 2 by 3 plus 2 by 3. It will be basically 4 by 3, right? So what is our power? Power is going to become V square by R. So now what is V here? Sir, it is 4. R is how much? It is 4 by 3. So it is 3 by 4. Power is going to become here 3 watt. Correct? So we are able to see that that is our correct answer. And that's it, guys. Thank you so much for joining. And if it was helpful, let me know. And I'll see you in the next one. Bye bye.